All right, moving up to the next question, in continuation to the topic of efficiency. So this is again and one of the question which appeared in your Cambridge exam, in which you have to after watching this block diagram, you have to tell what is going to be the output power. Acha, an electric motor has an input power P in. So these are the variables in which we have to play. So there's an input power. Efficiency is represented by a symbol eta n, and there is one output power which is shown as P out, and definitely the all of the power is not gone on the output. Some of the power might get lost as well. The question says among all these options A, B, C, D, which one is representing the output power? So how are we going to find out the output power? So let's begin solving its relation. We know efficiency is equals to what? It is equals to output power divided by input power. And output power divided by input power will be equivalent to what? The output power, we know input power is made up of both the output power plus the power which is being lost. The power which is being lost. So let's multiply the bottom part onto the left. So what it becomes? Efficiency will be equals to output power plus lost power is equals to output power. Is this fine? Next, we are going to multiply all of them. So efficiency into output power plus efficiency into lost power will be is equals to output power. So let's find out because we want to find out the output power. So let's make output power as a subject. So I am taking this output power to the left, efficiency into output power minus of output power will be equals to negative of efficiency into lost power. So when output power will be taken as common, which is efficiency minus of 1 is equals to negative of efficiency into the lost power. So what will be our output power equals to? Output power will be equals to negative of efficiency into lost power whole divided by efficiency minus of 1. So watching this whole relation, हमारा आंसर क्या बनता है? Our answer will be B, negative of efficiency into lost power divided by n minus 1. जी बच्चों, is this fine?
Yes, sir.
Okay, moving up to the next example. Shall I move onwards? Yes, guys, tell me, shall I move onwards? Okay, ji, I am just now shifting to the next part. Let's see what next it has to offer us. Yes, there's another question, and this is an exam question which also appeared in 2 to 3 multiple papers. It has been repeated, by the way. It came in 2019 paper, then it also came in 2015 paper. So let's see what is being asked in this question. A combined heat and power station, CHP station, it generates the electrical power and useful heat. So some useful heat is being produced and there is some electrical power which is given out as well. The diagram shows the input and output for a CHP station. So there is an input power from the fuel, and some of the power is wasted as 60 megawatts. Then there is some useful heating power as 160 megawatts, and then there is a useful uh, electrical power of 100 megawatts. Question says, what is the efficiency of the station for producing the useful power? Okay, student, इस diagram को देखते हुए, this is called as Sankey diagram, by the way. After witnessing the Sankey diagram, people, can you tell me how to solve this question? कोई भी ऐसा मुझे कोई क्लू बता सकता है क्या, कैसे सॉल्व करेंगे इस सवाल को एफिशिएंसी के? Yes, guys, any of the student or a kid sitting here who can answer me how we
तो
can solve?
टोटल आउटपुट पावर ऐड करेंगे तो इनपुट पावर आ जाएगी और रेशियो निकाल के फिर
शाबाश।
एफिशिएंसी।
तो हमारे पास टोटल फॉर्मूला हम यूज करेंगे, टोटल आउटपुट पावर, sorry, useful output power divided by total input power, which is multiplied with 100%. This is going to give us efficiency. So efficiency is output power over input power multiply by 100%, right? अब हमें एक बात, तो ये तो पता है कि हमारे पास यूजफुल आउटपुट पावर तो आ जाएगी, यूजफुल आउटपुट पावर है 160 एंड 100. So what is going to be the useful output power? The useful output power will be 160 plus of 100. This will be equals to 260 megawatts. What will be the output power? The output power will be 260 megawatts. And what will be the input power? The input power will be how much? The input power will be equals to 60 mega plus 160 mega plus 100 mega. And this will be equals to how much value? 260 plus 60 will be equal to 320 megawatts. This will be the input power, right? Now we have to find out the efficiency. Efficiency will be equals to, what is the output power? 260 mega. What is the input power? 320 mega. And this mega and mega cuts down, multiply by 100%. This 0 and 0 also cut down. And can anyone just solve it out for me? What final answer we are going to get for the efficiency?
81%।
So this will be equals to 81%. So correct answer in this regard will be D. Is this fine? How to solve the efficiency question, people? Good. Okay, this is one last question of this whole part, and after doing this, our chapter of work, power, energy will be finished. It will be completed. So we will be keeping further classes for practicing more past paper questions on the chapter of work, power, energy, and we will be using the concepts which we studied in this whole chapter, right? अच्छा माहीन, probably कल टेस्ट नहीं हो पाएगा because today it was off, and I again same the tomorrow, so probably there is no test going to be tomorrow. It is postponed, so I'll let you know the new date about the test, right? और मैं दो चैप्टर्स का कंबाइंड टेस्ट लूंगा. uh, the chapter of you can call it as electrical engineering, and so we will be having the test of both the chapters of deformation and work, power, energy together, right? So I'll let you know that combined date for its practice by next week. Okay, ji, so let's solve this question. There's another exam question in front of us. The diagram shows a pump which is called a hydraulic ram, and Question says in one such pump, the long approach pipe holds 500 kg of water. A valve shuts when the speed of this water reaches 2 meter per second. The kinetic energy of this water is used to lift a small quantity of water by a height of 15 meters. And question says the efficiency of the pump is 10%. Question says which mass of water could be lifted 15 meter. ठीक है, how much mass of water is going to be lifted by 15 meter. So this question seems pretty tricky, but it has used the word of efficiency, so your mind should be clicking with respect to that. Okay, we are going to take the help or we are going to use the concept of efficiency in this specific case. Okay, so it says the efficiency of the pump is 10%. It means the kinetic energy, the kinetic energy of the flowing water is making the water to lift upwards, right? So in one such this specific pump, the long approach pipe holds 500 kg of water and a valve shuts when the speed of this water reaches 2 meter per second, and the kinetic energy of this water is used to lift a small quantity of the water by a height of 15 meter. So it means input energy is going to be kinetic energy and output energy will be gravitational potential energy. So we are again going to begin from this concept that useful output energy divided by input energy. So from here we can say the output energy was gravitational potential energy and input energy was kinetic energy. And how much is the efficiency provided to us? The efficiency provided to us is 10%. So we are not writing this whole formula in terms of percentage. So we can convert this percentage into a simple value. So 10 divided by 100 will be equals to 0.1. So efficiency value is 0.1. This will be equals to gravitational potential energy over kinetic energy. And from here, we can also write that this will become 0.1 times of half mv square, and this will be equals to mgh. But mind one thing, both the masses are not same. The total mass which was falling was 500 of the water, and this is the mass which we have to find out जो कि कितना उसने ऊपर jump किया. So this will becomes what? 0.1 multiplied by half. The initial mass of flowing water is 500 and it is moving with a velocity of 2 square, which will be equals to, now we are going to find out the mass which is going to jump up. This mass is to be found into the value of g as 9.81. And how much it has jumped up? It has jumped up to a height of 15 meters. So after solving this whole relation, can anyone help me? I do not have the final answer written here. If we just multiply this whole part and if we multiply this right up part, what we are left with as a mass? The mass will be appearing as the Javaria, as per Javaria, it is saying that it is going to be 0.68. So how much the mass we are going to get? I think some student has solved it and they are answering at 0.68 kg. Is this fine? इसका सॉल्यूशन आपके पास यहाँ मैंने ऊपर लिखा हुआ भी है ताकि जब आप ये नोट्स पढ़ें तो यू शुड बी हैविंग अ solution for it as well. जी student, is this understandable?
Yes, sir.
Okay, so this is all about the chapter of work, power, energy, right? So you may just like prepare, you may notes share भी कर देता हूँ आपके साथ over the group as well, or you can prepare it from there as well. और आज हमारी क्लास है वो यहाँ पे